Okay, welcome to a short overview of the progress of my grader improvements. The center section is basically done. I still need to put a cover here, but the main thing is the rotating saddle is now done. So this part here freely rotates, and then we have this little servo here that moves a little key into the cutout cover of the saddle, and I'm going to use a servo saver. So the idea is that in this position I can use the arms to push off the ground and rotate the saddle to a position that I want. And well, obviously it will be very difficult to find the exact location of that cutout and the key. So what I can do is that I apply a bit of pre-pressure and then turn the whole thing, and cluck, it's locked in place, but as you can see it still has a lot of play. So if I increase the servo a bit more, it's now completely locked. So that is a very solid fix. Much better than ever before. So very happy how that worked. So happy in fact that I will take it apart and paint it, and not even going to go for a test drive. It just works so well that, you know, test drive would be good, but I have to put on all the cables and the routing and then take that off just to paint it, and I think I'm fairly confident that it will work quite well. So taking it apart, put Loctite into the connections that needed, and then yeah, paint it up. And you might be worried about how much power this servo needs to provide, and the answer is, in the actual clamping position, basically nothing, because you can see that this line is pretty much goes straight through the center shaft of the servo, and that means that there is no torque. So there is a little bit of flex in the plastic servo horn, and that's good. That prevents any slack from occurring. But the motor itself of the servo is not loaded, so it should not burn out. That's what those MG90 servos, well, all cheap servos really don't like, is being forced to provide a high current, a high torque all the time. So we can see again the same process. So move the servo out, saddle can freely rotate, apply a bit of pre-pressure. Now the servo is loaded at like half an amp. I turn the saddle and the key snaps in place, and I can then lock the servo, lock the saddle in place. And if we're looking at this, now we see 0.3 amps, and I move it out. So we see a little bit of movement, but yeah, so the current, if the servo is not doing anything, is 0.03 amps, 0.02. So literally during the clamping operation the servo motor has to do nothing. So that should be good for the servo, so that it won't burn out. Okay, and the next thing that I have completed is the circle section, and what I did is the moldboard mount. So previously I used plastic channel that goes around, that went around this back plate. That worked fine, but not sturdy enough, so I have now manufactured this from solid brass angle section, mounted to this square tube of aluminium, and then another brass section at the bottom. The top section goes all the way from here to there, so to prevent sand from getting near these near this back plate, and the bottom is only this section is brass, and that should be fine because when the grader is pushing down, this is taking all of the load, and so this is 10 millimeters wide of brass, so that's fairly sturdy, so we should be fine. You can't really see it, but in here we have two more screws. These screws here and there, they not only hold this aluminium square section, they also provide the sliding contact for the back plate. So they are made from brass as well, and this is anodized aluminium, so pretty hard surface. It's not perfect, but it's pretty good. So yeah, that's pretty much all there is to say. I had to redo one of those fishing rod lines, fishing lines. They snapped. Not because when I was dismantling, things went a little bit wrong. They are really sturdy, so seems a bit weird to use plastic at this, or polymers at this function, but yeah, fishing lines are really strong, so no problems there. And we'll have to see how, have a look how that works. So really happy how this works. This is not full power, so the power supply is at not even 10 volts, and I'm not giving full throttle. So yeah, really happy with that as well. Took a bit of planning to get everything to fit, but it fits now, and yeah, so I'm going to take that off, apply Loctite, as I said before, essential on this, because everything vibrates, of course, and yeah, should have it painted up, and also because the brass backplate that you can see, the brass not backplate, the brass guide, it's really flat, so it only goes 2 millimeters above the backplate, so really compact, and that allows me to put my rubber band here, so that all the sand that goes over the top of the moldboard will not get into that slot that you see here. So and that should then hopefully fall straight over the whole moldboard guide and not get into any of the mechanics. So that has worked really quite well before with the plastic. So yeah, I'm quite confident that this will also work once it's done. Yeah, and so with that finished, next up will be front motors. Lots of different motors I bought on eBay. I think that's not all. Ah, there are two more. Yeah, I assume they are all too weak, but I will test them, and once I know how strong the motors are and which ones I can use, I can then make a decision about redoing the front end. Because ultimately what I want to fix is the magnetic or electromagnetic interference that prevents my Arduino from working correctly. And yeah, so first step is going to be to resolder the suppressing capacitors on the motors that I already have, and if that doesn't work, then I have some backup motors. Okay, that's it for me for this time, and yeah, I hope to be back with some updates. Probably I'll talk about how I measure those motors, because, well, I hope that could be useful for some of you as well. And until then, well, have a good time. See ya!